So today we are going to talk about how we are going to move on Mars. We are going to talk about Martian rovers, specifically Curiosity and Perseverance rovers. And our speaker, Allan Treiman, he studies Martian rocks and Martian geology, and he knows a lot about Martian rovers.
Okay.
So people say hi, people say good afternoon. So, but before we start, I just want to remind everyone how we, the guidelines for our webinar, okay? So let's do that. So thank you for following our guidelines, and we will start now. I will stop sharing the screen and I will let our guest share the screen.
Okay. There. Okay. Well, good morning, good afternoon. I don't know which time zone you're in. Here it's late morning. I live in Houston, Texas. I work at an institute, the Lunar and Planetary Institute, and it's right next door to Johnson Space Center, where the Apollo lunar samples are kept and lots of meteorites from Antarctica. So I'm going to talk to you about the rovers on Mars. I've been very lucky to be involved in both the Mars Science Laboratory and Mars 2020 missions. So I'll talk about them, more about the Mars Science Laboratory with the Curiosity rover, because that's been going on, and a little less, but still some about the Perseverance rover on the Mars 2020, which with any luck will launch later this year. But first, Julia wanted me to tell you a little bit about myself. So let's see. Yeah. Okay, there I am. I was born in New Mexico in a town called Los Alamos, which was where the atomic bomb, the first atomic bomb, was built. And both my parents were chemists and worked on that project. And this is an aerial picture of the town of Los Alamos with this huge, beautiful mountains in back of it. And this is the town. I lived up in this area. My father worked here. And it was an unusual upbringing, I guess. But we were surrounded by mountains and there were rocks everywhere. And as a kid, I got interested in what all these rocks were and all the pretty crystals in them. And that was sort of how I got into geology afterwards. Still, it was funny that both my parents were chemists and I've ended up being sort of a chemist too. I wonder though sometimes whether I might have been happier doing something else. I've been very happy in the job I have, but I love music, and I wonder if I'd had a different childhood, whether I would have been a musician. But of course, in science, we like to repeat experiments, but you can't repeat experiments with your life. But still, I wonder. As I got to be a geologist, I was able to spend a lot of time outside in the field. And this is a picture of me on Spitsbergen Island, which is north of Norway, almost at the Arctic Circle. I'm standing there on top of a volcano, and here is a glacier right next door with a lake at the front of the glacier. That was an awful lot of fun. Right now, I spend most of my time in the laboratory and in the office, and this is a picture of our library at the Institute. And so working on Mars, I don't actually go to Mars. I sit in my office and just like you do, watch Zoom meetings or, WebEx or whatever it is. And I'm not actually on Mars, but it sure feels like it every day. I travel there in my imagination. So anyway, let's go talk about Mars. Let me try to move some stuff around on my screen. I'm trusting you can all see the screen. It's okay, Julia?
Yes, yes, it all works fine.
Okay, so we have a rover on Mars now, the Curiosity rover, and the U.S. is about to send another one this summer, end of July at the moment, we hope. And so this is what the view looks like on Mars from the Curiosity rover. But let me just back up and talk a little bit about Mars itself. Okay. Well, all right, let's do it that way. Oh, and I also need to apologize to everybody for the connection problems I had on Friday. I'm really sorry that I wasn't able to talk to you on Friday. It was very distressing. But anyway, I'm glad I'm here anyway. So this is a view from the Earth, from a computer program of what the sky looks like, of Mars, how it looks from Earth. And this would be early morning, say 5:30 a.m. in Houston time. And you can see a little bit of the light from the sun coming up. Mars is in the early morning sky, south to southeast. And all you see of Mars from the Earth is a little reddish dot. And we know it's more than that, but that's as much as you can see from Earth with your eye. Now, if you've got really good telescopes on Earth, you can see an awful lot more. And these are pictures taken from the Hubble telescope, the telescope that is orbiting the Earth. And I guess they've stopped working now. But Mars is a pretty interesting place, even looked at from the Earth. It's got lots of different colors, oranges and blacks and whites. It has ice at the North Pole and some down at the South Pole. It's got clouds. It has mountains here and here and here. We'll see these mountains again later. They're big volcanoes. It's an interesting looking place. It's got clouds. If it has clouds, it obviously has some kind of atmosphere, some air. We can see dust storms. We see ice at the poles, sort of like ice on the Earth's poles. So, what is Mars like? It looks sort of like the Earth, at least in this view. So let's talk a little bit about how climate and life is on Mars. Mars is smaller than the Earth. It's about half of the Earth's diameter, and these are space pictures of the Earth and Mars to scale. All these silly blocks here. So Mars is about half of the Earth's diameter. It's got less gravity. It's got about a third of the Earth's gravity. So I suppose that means if you jumped on Mars, you'd jump 3 times as high, which would be sort of fun. Mars's surface, though, is not very much like the Earth's. It has very, very low atmosphere pressure. It would be like as if you were, it's about 1/100th of the thickness of the atmosphere that it is on Earth. So this is sort of like being on Earth, I'm told, at 100,000 feet, which is something I've never experienced and never want to. The highest elevation I've ever been on the Earth is around 14,000 feet. And the air was pretty thin there. But higher, there's just not enough atmosphere for humans to breathe. Also, Mars's atmosphere is nearly all carbon dioxide. There's no oxygen to speak of in Mars's atmosphere. So humans would not be able to live at the surface. We would suffocate. See, the other part about Mars is it's farther from the sun than the Earth is. And so since a lot of the planet's heat comes from the sun, Mars is colder than the Earth. And here's this lovely graph that the Jet Propulsion Laboratory put together about temperatures on Mars and temperatures on Earth. And what they've done is they've compared seasonal temperatures from summer to winter to summer to winter in Los Angeles, California, USA, with the ones on Gale Crater on Mars, which is where the Curiosity rover is. And they picked Los Angeles because the Jet Propulsion Laboratory, which runs these rovers, is in Los Angeles. And it's a fairly pleasant place. And so you can see the temperatures in Los Angeles, for instance, run in the summer maybe up to 30 Celsius or maybe 90 Fahrenheit. That's for the highs, and then the lows are maybe around 15 Celsius, 70 Fahrenheit, 65 Fahrenheit. In the winter, it gets a little bit colder, highs around 20 Celsius or maybe 70 Fahrenheit. And it doesn't ever quite get down to freezing in Los Angeles, at least not very commonly. Now, Mars is completely different from that. The highest temperatures we ever see in Mars at Jezero Crater are around the freezing temperature of water. They're around 0 Celsius or 32 Fahrenheit. And that's in midsummer at the height of summertime, and in the late afternoon, the hottest part of the day. At night, even then, the temperatures are down around, let's see, around minus 65 or minus 70 Celsius, again, minus 90 Fahrenheit. In the winter, it's even colder. The high temperatures, like here or here, around minus 40 Fahrenheit, which is about the same as minus 40 Celsius. And the cold temperatures are like minus 130 Fahrenheit or minus 90 Celsius. This is colder than as cold as it gets in the mid of winter in Antarctica. So the temperatures on Mars are very much colder than on the Earth. And so even if we had people there and had atmosphere, oxygen to breathe, we'd still have to keep them warm. It's just not a very nice place for people at the moment. Okay, the other part about Mars is it's daytime, which turns out to be a really important thing for running rovers on Mars. Mars rotates like the Earth does, and it has daytime and nighttime. And here's a picture from the Viking mission long ago, which shows Mars. Over here is Mars at daytime, and here's the dusk line, and then over here would be Mars at night. So it's got daytime and nighttime, just like the Earth does. And just like the Earth, the day is almost exactly 24 hours. It's a bit of a coincidence, but the Mars day is a little bit longer than Earth's, 40 minutes longer. Now, the rovers on Mars have to run on Mars time because they take pictures and they need sunlight to take pictures. They need some of the heating that the sun provides on Mars to keep them going. And so, this difference in 48 minutes a day doesn't seem like much, but people on Earth have to adjust to it. So imagine we start out with rover operations, usually start around 10 in the morning. So imagine there's a day we start out where it's 10 o'clock on Earth and 10 o'clock on Mars, and we're starting our operations. Okay, keep working. The rover runs, we command it and tell it what to do. A week later, Mars time is 4 hours and 40 minutes behind the Earth time. So that means that Mars starts its day at 10 in the morning. We would start ours at 2:40 in the afternoon. Well, that's not too bad, is it? But take another week, and Mars starts its day at 10 in the morning, and we have to start ours at 7:20 in the evening. So, you're getting up at 6 in the evening, having your breakfast, going to work, and starting work at 7:20. And when do you stop work? 2 or 3 in the morning. Put another week onto it, and you start work at about midnight. So this is what we had to do for the first 3 months of operations on the Curiosity. And it worked okay for a while. For 2 months of the 3, we were all eager and happy and were so excited to be working on Mars. They just didn't bother. And about the 3rd month, we all ran out of steam, and it was very, very hard to get up at 2 in the morning and go to work. So since then, we now run on it. The rover runs on Mars time, and we try to accommodate as best we can on Earth time, but we still start around 8 in the morning and quit around 5. Okay, so much for that. How big is the rover? This is a picture of it being built with one of our scientists, Katie Stack. And both rovers are built sort of on the same chassis. It's like the same car, but different models. They're 2.1 meters high, around 7 feet tall, from the wheels up to the top of the mast, about 1.5 meters wide, They weigh 900 kilograms, which is nearly a metric ton. So they're big. And the Curiosity rover has lots and lots of science instruments on it. And I'll just go briefly over a couple of them, as we're not going to talk about all of them in this talk. It's got cameras all over the place. And the two most important ones are up here on top of the mast. There's a mast, a rod that sticks up. And there's cameras up there. And then there are also cameras out here on the end of the arm. There's a big, heavy arm, which lets us take the cameras and other instruments and a drill, which is this bit here, to put it up to the rock. And so we can sample the rock and get close analyses of the rock. There are also a couple of instruments inside the body of the rover, SAM and Chemin. Chemin is the instrument that I work with, and it uses a technique called X-ray diffraction to tell what minerals, what compounds, substances are in the rock. And let's see, there's also a weather station. At the back here is the power supply, this cylinder thing back here. Yeah. So those are some of the instruments. We'll only talk about a few of them here. Okay, so where did we land on Mars and why? Well, for the Curiosity mission, we landed at Gale Crater, and this is the picture you saw before, which is down here at the edge of this dark region and light regions. It's an impact crater, a hole in the ground right in here. And the next picture shows what the landscape there looks like. And Gale Crater is this circular thing. It's a hole in the ground. It was made by the impact of an asteroid long time ago onto Mars. And so it landed and punched a hole in the center, punched a hole in the surface of Mars. And it happens to be right at the boundary between southern highlands here, which have all these other round impact craters on it, and then the northern lowlands here, which have very few impact craters. And the difference in number of craters means that the highlands is older, much older than the lowlands. But Gale Crater is right at the boundary here. And part of the, let's see. So why did they pick Gale Crater, besides it being sort of a neat looking feature from orbit? Okay, the next slide shows the same area, but it's got weird colors on it. It's color coded for elevation. So just be worried, here it comes. Okay, wow. This is Gale Crater again, and the southern highlands and the northern lowlands, and the colors go with the elevation. So the red colors are high elevation. This is like 6 kilometers above sort of sea level. There's no sea level on Mars, so there's just a standard elevation is 0. 6 kilometers above, and then the holes in the bottom here are around 4.5 kilometers below that elevation. So there's a big difference in elevation here. It's almost 11 kilometers difference from here to here. Okay, so Curiosity's primary goal is to explore a region on Mars' surface for potential habitats of life, past or present. Mostly we're looking for past. That's what we're expecting. Now, I think you've heard talks about astrobiology. I think Dr. Brodsky has talked about those. And one of the critical things in looking for life elsewhere is water, liquid water. Liquid water is critical for life as we know it. We have to have liquid water in the cells and around us. And so that's sort of what we're looking for in other places. Now, Gale Crater is here. Why might that be a good place to look for liquid water? Well, the answer
let them guess.
Yeah, okay, I'll let them guess. We'll let you guess, and we'll come back in a moment to this. Why might this be a wonderful place to look for liquid water on Mars? So I'll come back to this in just a couple slides here and ask everybody. Okay, so while you're thinking about that, let me talk about the launch and landing of Curiosity. We launched on November 25th, 2011. This was Thanksgiving Day in the United States. And the rocket launch was an Atlas V, and it was a picture-perfect launch. With any luck, the launch of the Perseverance rover, the Mars 2020 mission, will look identical, we hope. And it launched, like I said, on November 25th. It's a long time to Mars. The way the orbits work is you have a short time where you can launch, and then you launch toward Mars. And it basically takes 9 months to get there. So the rover just coasts or cruises in between on its way to Mars. And we landed on Mars on August 6th, 2012. And there's a wonderful video you can find on the web of the landing. They took some video while it was landing. It's called, was it 7 Minutes of Terror? And I'm not going to show it here because it's too long, but it's a pretty interesting video of the landing. But it did land safely. The spacecraft, the rover disconnects from the spacecraft and deploys a big parachute. And the timing of this was just right so that one of our orbiters around Mars could take a picture of it. And they wanted to take a picture to see if the landing worked all right. And so this is the picture, I think it's Mars Reconnaissance Orbiter, of the Curiosity rover and its parachute drifting down through Mars's atmosphere. And here's a blow up in the contrast enhanced in that. And you can see the parachute, and this cross shaped here has to do with the weave of the fabric in the parachute. And there's Curiosity sitting in its shell beneath it. And you can't see the wires, the ropes between them, but they have to be there anyway. So we landed finally, safely. Almost none of us believed it would actually happen, but it did. And this was the first picture from the rover. This is a camera that's low down on the body, one of its hazard cameras. And what you can see is you see the wheels of the rover here. It looks sort of pigeon-toed, doesn't it, with the wheels pointing in. This is the shadow of the body of the rover. And in the background, you can see this big mound in the center of Jezero Crater. And then these black sand dunes. And we'll be seeing the black sand dunes a lot more. But okay, this is the time for getting answers. Here we are. I'm going to move back to the picture of Jezero Crater. And Julia, do you have any guesses as to why we picked?
Yes. So people say that because of gravity, the water will flow down. And if you expect to find water, it probably will be in the deep places.
That's it exactly. Exactly. I mean, if you're looking for water, you dig a well, right? Well, nature made for us a huge well here. They dug out this huge deep hole. So this is the place to look for water. This is the best place that we found on the planet, one of the best now. So that was why we went there. That's exactly right. You've got it. See, science isn't all that complicated. Some of the answers are just really straightforward, simple. Where do you go look for water? As low down as you can get. Okay. So that was where we landed. We landed in this deep well on Mars. And this is what the scene looked like when we got there. Well, there's no water here. If there were water on Mars, it would have been a long, long time ago. But this is what the scene looks like now. It's a desert. And any of you who have lived in a desert or visited one will recognize that this looks very much like deserts on Earth. It looks a lot like the deserts in the southwestern United States, Arizona, New Mexico. It's got rocks, it's got sand. This might have been some kind of river course. not real clear what it was. But it looks like a desert on Earth with a couple exceptions. There's no water there. There's no plants. There's no bird life. There's no animals. I mean, if this were in West Texas, for instance, in a desert there, this might be a good scene, but you'd be seeing little bushes down here at the bottom, little mesquite trees. But there's none of that. We didn't see anything alive at all and have not. So if there was water here, it was here a long, long time ago. All right. So this is another view from our landing site looking the other direction. And what you see are lots and lots and lots of rocks, of course. But there's also, this is the big hill in the center of Jezero Crater called Mount Sharp. And perhaps you can see that there are layers in this flat-lying stripes. These are layers of rock that were probably deposited in that water, in that lake that was in Jezero Crater. And the neat thing about this picture, this was taken 8 years ago. I mean, we're almost at, 8 years from landing, which would have been August 6th in fact, just a month from now, isn't it? So we've been there 7 years and 11 months. And where we are right now is over here. We've traveled across the planet, across these sand dunes, across these ridges, and right at the edge of this flat, this stripy surface here. It's been a long time. How long would it take you to walk, you think, to walk 14 miles or 20 kilometers? It took the rover 8 years to do that. I think I could walk 14 miles probably in a day. I'd be sort of tired at the end of the day, but probably in a day if I wanted to. Certainly 2 days would be no trouble at all. So we move very slowly. We move about 100 meters a day at the most. So it doesn't go so fast. Let's see. Okay, so this is a view from above, from orbit, of where we started out and a couple interesting spots on the way. And the inset up here is a side-looking view of where we landed. These are these black sand dunes, the mountain. And we're headed for this place called Gediz Vallis. Gediz is named after a town and area in Turkey. And so we've wandered across the fields, avoiding deep sand dunes and cliffs on the way. Started here. The picture I showed you just now was this area, Yellowknife Bay. And the next one I'll show you is this spot. It's called Kimberley. And this is the rover at Kimberley. And what you can see here, first of all, here's our big mountain in the background, Mount Sharp. These black sand dunes that we'll see in a moment. And the rover is positioned in front of these rocks. These are finely layered rocks. They're sandstones or mudstones. What you did if you took sand and mud and squeezed it together and compacted it and let it harden. And we're about to drill a sample here. And perhaps you can see there's this little discolored dot here. That's an area that was brushed off. There's a brush on the rover to clean off the rocks. And this is a good point to talk about why Mars is colored. Mars is, as you saw in the pictures, Mars is mostly reddish and black. And you see the scene here is mostly reddish and black. So we're seeing on the planet what same kind of colors we'd see from orbit and from Earth. But it turns out the rocks are actually not that color at all. The rocks are sort of green, which was a huge surprise. And it turns out that this orange color is dust. The planet is covered in this thin layer of dust. And so the whole thing, nearly the whole planet, looks orange because of the orange dust. But when you scrape away the dust, it's darker. So anyway, what we had here, we had these layers of rocks over here, sandstones and mudstones here and here. And the people that worry about rocks like this studied these and decided that, yes, these really are water deposited. These are rocks that were deposited in a lake a long time ago on Mars, probably 4 billion years ago. And it was a lake that was fed from streams that came out of the rim of the crater down into the lake. And we can see sandstones, which is like sand on the beach of the lake. And then as we went further along, we got into mud, which would have been at the bottom of the lake. So it's very much the same idea as a lake on Earth, but it was just happened to be on Mars. Now, this is a neat picture of the rover, and you might wonder, how do we get a picture of the rover? Is there another rover to take pictures of it? How did this happen? Well, this is a really clever thing that the engineers figured out how to do. This is a SELFIE. The rover's taken a picture of itself. And what you don't see here is the rover's arm. You saw that in the pictures before. The rover's arm would connect here, but it's not in this picture. Here are the wheels on one side. Here are the wheels on the other side. Here's the mast with its cameras on it that's staring down at the rock here. And you remember that there's a camera on the arm. And what they've done is take a series of pictures with the camera on the arm and paste them together to make this SELFIE. So the next image shows sort of a movie of how it takes its own SELFIE. And like if you take a selfie with your cell phone, you don't really want to have your arm in the middle of the picture. You want to have it out of the way. And that's what they've tried to do here. So here's the movie of how to take a selfie. And so it's got a camera. It's going to open up the cover on the camera right there. Pop. And then every time it stops, it's taking a picture. And you can imagine how much fun it must be planning how to move the arm to do this, how to make sure the camera is pointed in every possible direction, twisting the arm this way and that, round and round. And there we are. We're going to close the cover on the camera. Bleep. And this is what the selfie looks like. So they've taken a picture, it's not only of the rover, but the whole scene around it. Back up you there. So that's how it's done. Okay. Now let's move on a step. This is the sand dune. And this, I think, is one of the most beautiful pictures that the rover has taken. This is just a sand dune, but the sculpture on the surface is just, to me, beautiful. The ripples on ripples on ripples there. It's wonderful. Now, if you were on Earth and were on a sand dune, you might see things that we don't see on Mars, like you might see bird footprints, little bird tracks wandering across it, or might see lizard footprints as the lizards run across it, or maybe mice. Lots of signs of life you might see on the desert on Earth. There's none of those. We looked very hard. There's no sign of any living thing here. If it had been on Earth, there had been something, because life is so clever, it can figure out how to live even in the harshest deserts. But here there was nothing. So no life at all. Okay. One other picture I wanted to show here. This is a little further on our walk up to the mountain. This is a picture from orbit from the Mars Reconnaissance Camera looking down on our rover. And this is a ridge. This is called Vera Rubin Ridge. It's a very distinctive feature that we wanted to investigate. And we've now come beyond that. We've come down off of the ridge and are sitting down at the bottom here. And these are little sand dunes, white sand and then dark sand. And there's our rover. And this is what it looks like from orbit, which I think is just really cool that we can see it from orbit and see the stripe here is its wheel tracks. The big bluish part here is the power supply reflecting the sunlight. And this white spot at the upper right of the rover, that's the mast where the cameras are. So I thought that was really cool. Okay, so you remember at the very beginning, I pointed out where we are now on Mars. This is a picture of where we are now, or a couple days ago. We're actually just beyond this edge here, over in this plains. And here's our mountain again at the top. And so this is where we're traversing right now. The rocks in this scene have a lot of clay minerals in them, which means that they had a lot of water with them. Clay minerals only form in water. So this is part of the deposits from the lake. And so we're just finishing up studying of them, and we're going to go up toward the mountain and next. And so this next picture shows a view of where we are and where we're going. Now let's see. Just to orient you, this yellow line was the rover's traverse, and it looks sort of crazy that we wandered around a bit. The picture of the rover from orbit is here, and the picture I just showed you was taken here looking at this knob, this cliff right here. And this is the one that I showed in the very beginning of We Are Here Now. So we're sitting right in this area and looking. The intention is to go over here and start looking at these light-colored rocks. We know from orbital measurements that these have lots of sulfate minerals in them and not much clay. So there's a big change in environment. Something happened that made the clays go away and made these sulfur-rich minerals start forming. And that's something we really want to investigate, because this could be the big change in Mars's climate from being wet where it had lakes, like the one we've been wandering through in Jezero Crater, to a time like now where Mars is very dry. So we're going to wander up, make our way up onto this flat surface, and then wander up this river channel. This appears to be a river channel where there was water flowing and it carved out a big channel. A lot of good, a lot of very interesting scenery along the way, especially thinking about this area here where we're going to be looking into this deep valley with cliffs on both sides. And we'll eventually end up somewhere here. This will be in the next 2 to 3 years, we'll get up there. Eventually, the rover mission is going to stop because we're going to run out of power. We have a radioisotope power generator, and it's just wearing out. We know how fast it's wearing out. In 2 or 3 years, we're not going to have enough power to move the rover anymore. So we're trying to get in as much as we can before we run out of power. Okay, I can see I'm running too long here, but let's keep going real quick. The next rover is the Perseverance rover, and it's coming to Mars in 2021. It should launch later this month, and it's going to a very different place on Mars. It's over here, a place called Jezero Crater. And Jezero is a little crater. It's about 30 miles across. Jezero Crater was around 150 miles. And it's at the edge of a big impact crater here called Isidis, at the edge of a very large volcano called Syrtis Major. It's just a little crater on the edge there. And let's see. I'm going to have to cut this short because I've talked too long. But I think it's important to show this last video here. This is something NASA put together about why we're going to this Jezero Crater.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet high, and are the rim of Jezero Crater. The central goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today. But after Jezero Crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars' climate changed, Lake Jezero dried up and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero Crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
Okay. All right. I'm going to cut the talk a little short because I've run over. Just want to mention a couple things about the Perseverance rover. First of all, is it has a drill that can drill out samples of rock, and it's going to collect those samples and save them. And with any luck, in another decade, we'll send another rover to Mars to pick them up. So we'll get actual samples of Mars returned to Earth. And that's one of the big goals of this mission. They're looking for signs of life and want to bring rocks back so we can analyze them with all the fancy laboratories on the Earth. The second thing is that we're going to have a small helicopter. This is going to be the first time we've ever had a flying machine on another planet. And it's a fancy version of one of the little drone helicopters that you can get yourself. But it's going to be carried to Mars. It'll be on the underside of the rover. It'll be dropped off at some point, and it'll, with any luck, take off and fly. Make some really pretty pictures and help us with planning where the rover is going to go. Okay, so the timeline for this launch is supposed to be this month. It was supposed to launch on July 17th. It's now been delayed till July 30th, and we surely hope that it launches. It doesn't have, there's a limited time that a rover can launch from Earth to Mars. So it doesn't have a lot of time left. They've had some problems with the rockets at Cape Kennedy. So it'll cruise to Mars through early 2021. It will land on Mars in February 2021 and begin looking at the rocks in Jezero Crater. And we all hope this happens on schedule. So anyway, that's what I've got to show you, and good night from Mars. And I have left at least 15 minutes for questions. So thank you. Thank you all for listening and your attention. And what kind of questions do we have, Julia?
Oh, we have lots of questions.
Oh, I'm sure.
So, first of all, thank you so much. It's like, we can see that you have this, intimate knowledge of what's going on that planet, like that you actually spent many years studying it. So we feel like we were there with the rover
I'm glad you do. I have had so much fun doing this. I hope my enthusiasm for it came across. This has just been an enormous fun and just so exciting to really sort of be running a rover on a different planet. That's, I would have never imagined I'd do that. Okay, so what can I answer?
Yeah, many questions here. So okay. The first one, since you say that there was water on Mars, what happened and at what time the water disappeared from Mars?
Where did the water go? That is,
Mhm.
a really, really good question. And there are a couple answers to that. No one's really completely certain about that. Some of the water escaped into space from the top of Mars's atmosphere. Mars doesn't have a magnetic field like the Earth does. And the magnetic field helps keep Earth's atmosphere in. On Mars, there's no magnetic field. And so when the water, the hydrogen in the water, gets up to the top of the atmosphere, as it just sort of does as the atmosphere turns around, it can get blown off into space by the solar wind. We have a spacecraft there that's studying that now, the MAVEN spacecraft, learning exactly what happens, how fast it happens. So that's one answer. The other answer is that Mars froze probably around 4 billion years ago. Mars was warm enough early on to have liquid water flowing across the surface and to make big lakes like in Jezero and in Jezero Crater. And somewhere in there, Mars got cold enough that the water all froze out. And so there's lots of water underground on Mars. There's ice at both poles. And the Phoenix lander, oh gosh, I forget how many years ago that was, landed fairly far north on Mars. And it had a little scoop and scraped at the surface. And within a couple centimeters, it had hit solid ice. So there's a lot of ice there just underneath the surface. And I think that's where the water went. A lot of it blew off into space, and the rest is there but frozen.
So a related question here about underground caves on Mars.
Yes.
Filled with water.
Are there caves filled with water?
Mhm.
There could be, of course. We haven't found any yet because it's hard to know what's going on underground. There are caves on Mars. We know this because of the orbital images have shown holes into Mars. These are probably lava tube caves that form in big lava flows when the outside of the lava flow freezes and then the liquid lava inside just flows out, leaves a hole there. So there are quite a few caves like that are known on Mars. And they're seen as just little circular holes in the surface. And from orbit, you can even see deep down inside and sometimes see the bottom of them. And in those, there could well be ice. Like on Earth, caves are often colder inside than the surroundings. And so it's likely that there are ice caves on Mars. Whether there's liquid water, probably not, but no one knows for sure. Something that's sort of related to this is one of the instruments on the Perseverance rover is a ground-penetrating radar device, which sends radar beams like a policeman might use to catch if your car is speeding. But it sends it down into the ground, and the radar will reflect off of boundaries, layers in the earth. And with that kind of thing, maybe we could see a cave and maybe see if it had liquid water in it. I mean, at the moment, no one knows. There's no evidence for it either way, but it's interesting thought. Okay.
Yeah, thank you. Yes, I guess it's great, that Perseverance will actually give us some new capabilities. So, like that. So, what are your major concerns about what might go wrong at any point during the mission or before the mission?
There's so many things that could go wrong on a mission like this. We've had, like on the Curiosity rover, we've had problems with our wheels. We didn't understand what the surface of Mars was like, that it had lots of really pokey rocks on it. And so our wheels have holes in them. And it's okay. And the new rover, the Perseverance, has better wheels. We've had computer problems The rovers have two computers on them, a main one and a backup. And on the Curiosity rover, the main computer died, I don't know, 3-4 years ago. And so we've been working on the backup computer just fine. So those are always dangers. Probably the hardest thing on any spacecraft mission, hardest things are the launch and the landing. With the launch, as you know, any number of things can go wrong. Rockets sometimes blow up. And a landing, you know, it's difficult to land on another planet because the spacecraft comes to the planet going very, very fast and has to slow down a lot. It's like a spacecraft coming back to Earth. It has to go through the atmosphere. It heats up a lot with its heat shield. Then the parachute has to come out just right, and it has to carry it down properly. A lot of places that can go wrong. With the Perseverance rover is using the same launch and landing method that the Curiosity rover did, and even an improvement on that. So it worked for Curiosity. It'll probably work for Perseverance too. But spacecraft work is hard, and there are a lot of places where things can go wrong. And of course, the big issue is if you're on Mars, you can't send anybody out to repair it. You're stuck. Okay. I don't mean to sound too negative, but there are lots of things that can go wrong. And the JPL engineers are very good in thinking about them and have planned against most of them. So we'll see.
Another question is, how deep are you going to drill this time with Perseverance?
How deep? Not very deep, only a couple centimeters. Drilling on another planet is pretty difficult. In fact, drilling on Earth is pretty difficult. If you've ever seen a water well being drilled or an oil well or people working a mine, it takes a lot of effort to do that. And we don't really have on these rovers a lot of power or a lot of time. So what they'll be drilling are little cores. They're about a centimeter and a half diameter, and maybe a couple centimeters long. So it's not much. Yeah.
So are there any signs of previous life on Mars?
Oh, I wish we could say yes, but so far, no. That's a whole nother talk I have about signs of life on Mars. We haven't found anything that the scientists believe looks anything like life. As I said, we've seen nothing in the sand dunes. It might be current life. We haven't seen anything in the rocks that looks like a fossil. Even relics of bacteria, we haven't seen anything like that. Now you will find on the internet all kinds of weird shaped rocks that people say have to be signs of life or ancient civilizations or crashed spacecraft. They're not. People have really good imaginations, and if they want to see an alien spacecraft, they'll see an alien spacecraft. So no, unfortunately, we haven't found any signs yet. Gale may not have been the best place to look, but Jezero is a much better place. And so we're really looking forward to that on Jezero.
People ask whether you prefer one hemisphere of Mars to another one, and if yes, why?
One hemisphere?
Mm-hmm.
Oh, boy. Well, that's a really hard question. I think the answer depends a lot on what it is you're looking for on Mars. Hang on just half a second here. If you're looking for the ancient history of Mars, then you'd want to go to the highlands, the southern part, because that's where the older rocks are, that area I showed that had all the impact craters. If you're looking for signs of life, probably it wouldn't be so much the hemispheres, but it would be craters where there were lakes, as we've done with Gale. the Gale Crater and the Jezero Crater. Yeah, I don't know. That's a really hard question to answer without knowing what it is you're really looking for. So I'd ask whoever asked that question to say, what is it you would like to know most about Mars?
Yeah, I think they were looking for the signs of life.
Signs of life. Okay.
Mm-hmm.
In that case, yeah, I think to my mind, we're doing the right thing in looking at lakes. If you look at river valleys or stuff, whatever life might have been there might have been washed away, and it'll end up in one of these lakes. So that, I think, is the best place. Yeah.
How much ice do you find on Mars?
How much ice? I wish I knew how much there was in total. The deal is we don't know how thick the ice in the north is. Like I mentioned, I said that this Phoenix lander scraped at the surface and saw there was ice only a couple centimeters down. Another interesting thing is that there have been in the time we've had orbiters going around Mars, there have been some asteroids that have hit Mars, small ones, and made impact craters and excavated into the surface. And some of those in the northern plains have, after the crater's been formed, the walls of it are really white. There's almost certainly ice. And then after a while, the ice sort of disappears. It gets covered with dust. But certainly looking at hundreds of meters of ice at least. We really don't know how deep that might be, but there's a lot. There's a lot there.
Why the dust on Mars is yellowish and reddish? What is it made of?
Why is it yellowish? Well, it's the answer is the same that people have had forever about Mars, that it's rust. It's fine-grained iron oxide and hydroxide minerals. It's the same stuff you'd get on rusting iron on Earth, or nearly the same. What's been a surprise is how thin the layer is. When people have looked at Mars and said, "Oh, it's bright, it's red, it's rusted, the rust is deep." It's not. What we know from Gale Crater is that this rusty layer is only dust at the surface, and if we scrape away its rock, it's greenish, grayish rock underneath. So it's rust, but it's not near so much as we thought before going to Gale Crater.
So another question is that if it is rust, you need oxygen, and do we have oxygen at Mars? Have we had oxygen at Mars?
Absolutely, you must have had oxygen, and also water, because of course if you have iron metal without any water, it doesn't rust. So yeah, this is a sign that somewhere, sometime on Mars, there was a lot of water and there was more oxygen in the atmosphere. It might be that just there's enough oxygen from the carbon dioxide itself to make the rust. I'm not sure about that. But there certainly had to be water, and it had to be pretty extensive to make the rusty stuff that we see. Whether it was, and it's hard to know whether the rusting was all over the planet or there was just some single spot that produced an incredible amount of rust, and then the wind distributed it all around. We don't know that. That's going to take a lot more exploration to discover.
Very interesting.
Yeah, and of course, if we can bring back some of the dust with the samples that Perseverance has collected, certainly we'll bring back some of it. And when we study that on Earth, we'll learn an awful lot about how it formed.
So there is another question. We know
Yes.
that human cannot last on Mars without a spacesuit because of the, very low pressure
Yes.
and, of course, lack of oxygen. How does it affect the rover itself?
How does it affect the rover? The rovers are designed to work without atmosphere pressure, to work under Mars pressure, and they test those on Earth in huge vacuum chambers. So it's like a chamber that's big enough to fit the rover, that can be, where the pressure can be reduced to the level that it is on Mars. And they test out all the mechanisms there and make sure that they work. The pressure is not such a big thing for the rover. What's a much bigger problem for the rover is the temperatures. I mean, it's colder than on Earth, and the temperature range, as I showed, very beginning, from daytime to nighttime is just amazing. It's huge. And that's a problem for mechanisms, for motors and stuff, because most materials, metals, they swell, they get bigger when they get hot, and they get smaller when they get cold. So all the mechanisms have to be able to, to work when they're warm, when they're expanded, and work when they're cold, when they're smaller. So that's a real problem. It's really hard on electronics. So what the rover has done, what they've done with the rover, is that inside the body of the rover, there's a box that's heated all the time. It's called the warm electronics box. And it's heated to about room temperature, 20, 25 degrees Celsius all the time. So the electronics don't have to deal with the expansion and contraction. So yeah, the pressure, not so much a problem, but temperature is a real engineering challenge.
Very interesting. So it's about time, so I'll ask you one more question, and
Sure.
we probably will have to wrap up. So, so the question is, when do you expect the samples back?
That's a very good question. If we're going to get samples, when do we expect them back? Well, no one quite knows yet. The plans for the rover and spacecraft to retrieve the samples are still very much just drawings on paper. Probably, I think the best plans would have them coming back by the end of the 2020s, maybe 2029 or 2030. It'll be an interesting scheme to do this. The way they're looking at it now is to have two separate spacecraft go to Mars to do this. One will be a lander that will have a little rover, a fetch rover, that will go and collect these samples in their storage tubes. Go and collect them on the surface, bring them back to the lander, and put them in a rocket on the lander. So they're going to take a rocket to the surface of Mars, and that will launch the samples off of the surface of Mars into orbit. And waiting up there in orbit is going to be a second spacecraft, which will somehow catch these samples. And I imagine this huge butterfly net waving around in space trying to catch the sample container. But that's sort of the plan right now, is to have two separate spacecraft that'll go up, one that'll land on the surface, collect the samples, and send them into orbit around Mars, and a second one which will collect the samples in orbit and then bring them back to Earth. It's very complicated.
Amazing. Yes, yes.
And I think the plans are for the US to collaborate very closely with the European Space Agency, ESA, on this. So it's a lot. It'd be a lot for a single country to do on its own.
Pretty amazing. Yes.
Okay.
So, well, thank you so much. If you want, we have actually more questions here. So, but I'll forward them to you. If
Okay.
you want.
Yeah. If you could do that, please do, and I will write back answers to them. And thank you all so much for listening to me. And please pay attention to the Mars rover launch. It's scheduled for July 30. It ought to be on television or on the web. I think NASA has a YouTube channel that you could see it on. And we're all hoping that the launch goes well. Cross my fingers and wish for the best.
Yes, we definitely all will be watching.
Yes. Okay. And thank you so much for tuning in this time. And again, my apologies for the connection problems on Friday.
So people in chat say it was so interesting, fascinating. We'll be watching for lunch and hoping for the best.
Wonderful.
And so, yes.
Okay. Well, thank you all very much. And
Thank you again. That was like a journey to Mars.
yeah,
I felt like as I actually traveled there.
yeah, it's an exciting place. It's familiar but different, and just always something new around the corner to see. Very exciting, and just so for me, it's just a thrill to know that I'm helping drive this robot on another planet. It's just wonderful, great feeling. Sometimes in the middle of a day's operations, we're planning what's happening this second and the next second. It's hard to remember what it is we're doing because you worry, well, do we have enough time for this activity? Was enough power for that one? But then we stop back and think, gosh, we're running a rover on another planet. How cool is that? How wonderful is that? So
I actually asked the kids at some point to develop a Martian calendar. So because, the year is twice as long and so on. And they were asking whether we have any names for Martian months or whether we actually...
No, there's
not yet.
Not yet. No, the business of a Martian calendar, they've been talking about that for a long time. There's wonderful, wonderful ideas on that. We've never done that. What we do on the mission is we just count days. So we landed on day 1, or Sol 1, as we call the Martian days, Sols. And we just count from landing. So right now, for Curiosity is on Sol 2,830 or something like that. But yeah, it would be nice to have, when people go there, we will need a calendar. We will need to have some way of chopping up time into chunks, weeks and months. The year is about twice as long as the Earth's. It'll be interesting to see how they'd work it with days, since the days are similar but not quite the same. I think our human, our biology that fits us for 24-hour days will be just fine on Mars. But how we do the weeks and months, I have no idea. We'll have to wait till people get there to decide that.
Yes, quite interesting to see what they will come up with.
Mm-hmm.
Well, thank you so much.
Okay, well, thank you so much again. And I will have to leave. I have a meeting that starts probably a few minutes ago.
Sorry. Sorry.
No problem, no problem. This is much more fun. Okay.
Thank you so much. And goodbye, everyone.
Okay.
Thank you for coming. I'll end the meeting now.
Okay.
Thank you.
I wasn't seeing how to disconnect yet.